Hey everyone. In this session, we will discuss about open close principle in solid design patterns. This is our second session in design pattern series. As usual, we will go through the definition, try to understand the definition with real world example. Then there will be a live implementation and I will try to create a visual representation as well with the diagrams so that it would be easy to follow the code. I would suggest to watch the whole video at a high speed. OCP states that software entity should be open for extension but closed for modification. Now, instead of explaining this definition, let's walk through the real world example because that would break down this definition and it will start making sense automatically. Let's consider MacBook. It is essential tool for developer and there are other accessories as well which we usually use with MacBook. For example, consider headphone and mouse. Now try to think about the process which we usually follow to connect mouse and headphone with MacBook. We just have to turn on the Bluetooth and they will seamlessly connect. So by connecting headphone and mouse with MacBook, we have extended MacBook functionality. Instead of playing song on MacBook speaker, now we can play it on headphone. Similarly, we can use mouse instead of touchpad. This is exactly what open for extension means. Your class should be able to extend its functionality as required. Companies have designed these devices in such a way that we didn't have to go around with screwdriver and open these devices for connection. And this is intentional design. So for extension, we didn't have to modify any of the existing feature. This is what meant by close for modification. We should not modify existing class. So in our example, we connected headphone and mouse with MacBook without removing or modifying any of other functionality. If we consider MacBook as a class, then we can say that it's in the same state as before. So with open for extension, we mean that software component should be extendable to add new feature or new behavior. And close for modification means that a new feature which we are adding should not affect or change any existing behavior or code. If we are modifying any existing class just to have a new feature, then we are not following open close principle. Let's have a look at some of the benefits which we get with open close principle. It's easy for extension. You can easily add new classes without worrying about the existing code base. Testing will be much easy. Now, this doesn't mean that you do not have to write test case at all, but at least we will be able to test new functionality only. And running these test cases for new functionality is much easier than running the regression for the whole system software. Just ask any QA tester and they will vouch for this. The other point is that it promotes SRP principle as we are delegating extra responsibilities to other classes. Now there are a few points which you need to consider before applying OCP. We should not follow this particular principle blindly. Otherwise there will be a lot of classes which will be hard to manage and overcomplicate the software design. So if you see an issue, then you can just send the fix for that particular issue only instead of playing with the design. But if you see multiple issues and you are sure that they can be fixed with this particular design pattern, then go ahead, use it. Using OCP is more of a subjective decision or choice. Now we are going to consider these diagrams and create program in parallel. So this way you will have a better understanding of what our code is doing and what we are exactly trying to achieve. Let's define product class with these three data members. Let's create a constructor as well for this particular class. Now let's also generate some getter and setter methods. So I guess we do not need setter method now, so we can just go ahead with the getter methods. Okay, let's add header file as well. So we also need to define these two classes. So instead of let's create enum class for color, and let's create three color: white, red and black. Similar way, let's create another enum class for battery size. So that would be large, medium and small. So we have defined these data members. Now start creating these objects as well. Now let's define our main method. And create 4 object here of product type. So first product, let's consider phone with color, I guess, white, and battery size will be medium. Now let's create another product. Let's call it watch. This will be of color black and battery size will be small. Similar way, let's create another product, headphone. Color will be white, or let's just go with black. Battery size will be medium. Now let's create another product, and that was laptop. So the color will be, instead of red, let's go with space gray. And battery size will be large. So we have created our objects. Now let's just add them into an array. So let's get a vector of product and let's call it bag. So in our bag we have a phone, watch, headphone and laptop. Let's add vector header file as well. So I guess we are done here. Now let's just say we want to filter these objects. So for that we need a filter class. Now if we are going to filter these objects, then we need to consider one of the parameters. So how exactly we are going to filter these objects? Whether we are going to filter these objects with the color or we are going to filter these with size. So initially let's just say that we want to filter these objects with the help of color. So we will create another method here which will return a list of filtered item. So there will be a vector and it will be, let's call it by color. It will take an vector and it will also take an color with which we are going to compare these objects. Now let's create a result vector here which we are going to return. Now let's iterate all of the items which are present in our bag and let's check if that particular item has color matching to the color which we want it to have. In that case, we will add it to our list. Now let's call this particular method here. Let's make it static so that we do not have to create an extra object. Now let's pass it our back, and the color which we want to filter out is black. Now let's add another header file here. And I guess it should run fine. So it says watch is black in color as well as headphone is also black in color. So till now everything is fine. Now let's just say we want to add or filter with another parameter which is size, battery size. So we want to filter out all of the objects which have a small battery. The only way which we have to do that is extending this particular class. So we need to add another method here which will take size as a parameter and then return the objects which have that particular size. So what we could do is just need to copy paste this method and add change few parameters. So by size, this time it will be size and battery size. This will be size and we are going to get a battery size. So I guess that's all, and we just need to copy paste this as well. Now let's print a few new lines. Now if you run this particular program, it says that watch has a small battery. So we can see that particular thing in the watch object itself, that it indeed has a small battery. Now let's just say that you got another requirement to filter out these objects with size as well as color. Now again you have to follow the same process. So let's just go with that. We are going to copy paste it again. This time it would be by size and color. So this will take another parameter color, and it will compare it here. Then push back and it will return this particular result. So let's just copy paste it here as well. This will take, so this time let's change the requirement. We want the battery size to be medium and color to be black. So let's run this program again, and we can say headphone has a medium battery size as well as black in color. So now we got the problem here. Each time we had a new requirement or had to add a new functionality, we have to update filter class, and this was clearly violating OCP principle, which says that if you are extending functionality, then you should not modify the existing feature. And in this particular case, whenever we need to extend our functionality, whether it's in searching or filtering by color, by size, or by both, we have to modify filter class. So this was an issue. Now we have seen the problem, so let's try to talk about the solution. What we are going to do is create another class, and let's call it specification class. It will contain a pure virtual boolean method is satisfied. Now for each requirement, we will create a separate class, whether it's size, color, or by both, and these classes will be derived from our specification class. These classes have to implement the pure virtual method and define it. The filter method will take specification class object as an parameter, and within that method we will call this particular method is satisfied. And on the basis of the output, whether it's true or false, it will be true if that particular item which we have in our bag have the required color or the size, and otherwise it will return false. This way we will filter out the object and return the list. So let's see this particular logic live in action now. Now we will move this particular code, and you can delete this particular code, but I will keep it so that I can post the link for this whole code in the description section. So let's call a namespace and bad code. So this was a bad code. Now let's start the implementation again. This time I'm using templates. So what we need is specification class. And this will take an item. So our specification class is ready. Now let's create our filter class again with template. So this particular class will contain another virtual method, and let's call it filter. It will take an product bag, so there will be a vector which will be containing all of our items, and then there will be an specification as well. Now our basic design is complete. Now let's create our product filter class, which will be derived from filter class itself. And it will override this method. Now we need another list here. Let's call it product result, which we are going to return, and let's iterate over the bag item. If that particular specification, and specification here could be size or color, is satisfied by this item, then we will add it into our result list. And then we will return it. So we are done with the product filter class, and let's create an object as well. I will keep it here. This will be our PF method which we use to filter out these objects. So again, let's say new requirement comes and we have to filter out these objects on the basis of color. So this time we need to create a color specification. So here is our specification method. So let's create a color specification here. So class color specification, and which will be derived from our specification class itself. Now this will override this particular method. And we will just return whether this particular item has the color which we need. Now from where we will get this color is by adding a color inside this color specification. So this will be color, and let's generate a constructor as well. A lot of colors, huh? So I guess we are done with the color specification class. So here we can create an object. So let's call it white color. Now we have created a color classification, color specification as well. So by using our PF object, we can filter out the bag. We can filter out the items present in the bag, and we need to pass white color here. So let's run this program now. And it says phone is white in color, and we can see that thing. Our phone is in white color. So let's again say that our requirement changes, and we need to filter out these objects on the basis of their battery size. So for that we need to create a battery specification, and notice this time we are not going to change filter class. We say that okay, now we need to filter out these objects on the basis of their battery. We create a battery specification class. Let's call it battery specification, or let's call it size specification, which will again derived from specification class. And this will have a battery size. Let's create a constructor. And we need to override this method again. I don't know why C-line is not happy with this implementation. This will be satisfied if we go to the battery size which we are looking for. If we are looking for medium, then we need to get a medium battery size here as well. Otherwise this will return false. let's remove this one, and again we can just pf filter. Here we need to create an battery specification size specification class. Let's create an size specification object here. Let's call it medium battery. Battery size will be medium, and this object we can use here now. If we run this particular program here, it will say that phone has an sorry, I think we need to change this as well. Yeah, phone has medium battery size, as well as headphone has a medium size battery as well. We can verify it here. Now you have seen it already, that whenever our specification or our condition changes, we do not need to modify our filter class. Now let's the final example, where we are going to filter out the object on the basis of size as well as color. For that, again we need to create another specification class, and let's call it end specification, because we are looking for those objects which have these both of these condition matching. So if we are looking for either size or color, then we can just say that now we need to create an or specification class. In this particular case, we can create just an end specification class. So where we are going to do it, this is size specification and this is color specification. So let's implement it here. Class, which will again derived from our specification class. Now this time it's a combination of two other specifications. And what are those specifications? Color specification and size specification. Okay, this will override this particular method as well. And there will be product. It will return whether this item so whether our color is satisfied by this item and our size, battery size, is satisfied with this item. If this particular item is satisfying the color conditions and our battery size condition, then this condition will be true, and then each satisfied method will be happy. So let's create an constructor as well for our end specification class. This will take color specification object and size specification object as parameter. Yeah, I guess this will work fine. Now we need to define an object here for our end specification class. This will size and color. So we can pass white color, so we can pass white color and medium battery. Do we have an object? Yeah, we have phone. So here we do not need to pass these. We can just say that take size and color as an object, and this will be simple pf.filter. Now this will say has medium battery size and black in color, but We have created a white color object. Let's run this particular program. And it says phone has medium battery size and white in color. So what we have done is we have connected these methods here. And these became a new specification class. This way, now if we are going to extend our functionalities, we can just add new class here and attach this particular class to our interface. Our filter class will remain unchanged, and now we can see that it is following OCP principle. Thank you for watching and see you in the next session.